Thank you for having me, and thank you for the very kind introduction. So, as was said, my name is Jesse Wright. I'm currently doing a PhD working on ethical web and data architectures. It is a technical PhD working on things from neurosymbolic AI through to trust and provenance and data management. And in my day job, I'm leading the Solid project at the Open Data Institute. And I've been working in the space of Solid for a number of years now. Prior to the PhD, I worked as an engineer at Inrupt, which is Sir Tim Berners-Lee's startup building an enterprise-grade implementation of the Solid service. So, what is Solid? Well, let's first look back at the web and the history of the web. And this very nice image here is from the 2012 Olympics, which encapsulates Tim's original vision, which is this is for everyone, a platform for people to create and design and to share knowledge and to be an open, decentralized space for information. And if we look at the early days of the web, there was a lot of freedom, a lot of creativity, people creating their own websites like WebNode. There was a absolute boom in the early 2000s with the dot-com boom. And then there became this era where people increasingly are being disempowered online as we've had an emergence of centralized platforms like Facebook and LinkedIn and MySpace back in the day, who are all creating their own silos of personal data and trying to lock individuals into given platforms, making it very hard to migrate once all of your data is in a particular setting. And the goal of Solid is to unlock data from those silos and give people back and companies back and other groups back control of their data by decoupling information from applications on the web. And as this quote here, the Solid's vision and now the shared vision with ODI and the stewardship work that ODI is doing is to establish a data ecosystem that benefits individuals, organizations, and society. So let's have a look at what Solid is from a technical standpoint. Solid can be thought of as a new set of protocols on top of the existing, and it's been termed Web 3.0, and we've been using the Web 3.0 term for solid and semantic web technologies long before the blockchain community has claimed the Web 3 terms. So I'm going to continue to use Web 3.0. And there's three fundamental things that Solid for a server to client protocol adds on top of the web, the HTTP specifications. The first is single sign-on and global identity. So today, when you're doing single sign-on, you can delegate some of your identity to Google or to Facebook when you do your login with process, but you're requiring those particular providers to manage your identity for you. Solid uses similar IDC mechanisms to instead allow you to choose your personal data store that you want to use, that may be self-hosted, that may be hosted by a trusted provider, that may be hosted by a trusted education institution, whoever you choose, and to authenticate and log into your pod using a single sign-on flow. The next thing that Solid adds is a set of standard ways to read and write your data to this personal cloud storage. And those are HTTP methods for reading and writing, and the linked data platform is what this is based on. The third set of things that Solid adds as a core server to client protocol is access controls. And those access controls allow you to define which entities, which people, increasingly which agents, have access to your data, as well as what applications can access your data when you're using it. For instance, I may want to give social media applications only access to some of my photos and some of my posts when I log in, and not all of my sensitive financial data that also lives on my pod. So there's authorization for both applications and individuals. And increasingly, we're starting to see the use of delegated and token-based access control models in Solid as well, to allow you to go and get what's called an access grant that may indicate you've got permission to access medical resources across pods because you're a GP practitioner. So that allows more role-based access control to data as well. And as I said, it's the third layer of the web. So it adds single sign-on, authorization, and a universal API for reading and writing data. But it's not just about the client to server protocol, because I don't just want to have control over my data. I want my data to really work for me, and I want to be able to reuse it across applications. For instance, I want to have an authoritative source for my address, and then for that address to be available to my bank, to my educational institution, to social media platforms when I sign up. And if I move, I don't really want to have to go through the laborious process. I've done this several times, moving from Australia to the UK, for instance, of having to go to all of the institutions that I work with and say, okay, I've moved, here's my new address, here's all the forms, and go and fill out a set of forms with them, go through 20 sets of two-factor authentication, realize I've forgotten a password somewhere, have to talk to someone on a phone. I don't want to have to go through that process. I want those applications to be able to read my authoritative source of my address on demand and be able to reuse it. So it solves a very simple use case of address, and then we can extend the benefits to all of our data. Think about what can happen when my health records are available to trusted predictive analysis as I want. Think about what I can do when I want to share my finances to be able to get a home loan and not have to go through the process of getting the records from banks. It's really making your data work for you. But in order for that to be practical at a technical level, clients need to understand each other's data and not just in a hope for the best LLM interpreted this kind of way. And this is where RDF and linked data come in. They allow for shared data models and data discoverability. So I'm going to start with linked data. Linked data is a concept proposed by Tim Berners-Lee, and there's 4 core tenets to linked data. You should use URIs, which is a generalization of URLs, to name all things. When you use those HTTP URIs, and you go to that HTTP URI, it should provide something useful back to you, either in a machine-readable document or by presenting a query API to allow you to discover more things. So if I look up the address for Jesse, I should be able to discover things like my friends, my date of birth, my address, provided I have the right permissions. And those URIs should be HTTP so that I can do that dereferencing. And as I said, there should be discoverability. In addition to linked data, which allows you to do this discovery process, we also need to have meaning within our data. We need to have good data modeling. And this is where the RDF aspect comes in. So not only do we publish our instance data using URIs and using machine-readable formats, we also publish our ontologies, our data models, using RDF. So this example here is of the wine ontology, and it describes the ways that you can model wine so that any application that wants to talk about wine, that wants to describe white wines they've got in their cellar, that wants to advertise white wine online, that wants to pitch white wine to you in an ad, all use the same way of describing white wine so that they can read each other's data. That is the core tenet of RDF. So that allows us to add this layer on top of the client-to-server specifications, which was the universal API, the solid login, and the solid authentication, of domain-specific protocols, which are just data models that are discoverable for domains such as health and finances and recipes and preferences and fitness and media and tasks and chat and context and nutrition. That is what Solid is about. Data reuse, the way that you want it. And this is kind of an example of what this data looks like under the hood. So this is my web ID. This is the URI or one of my aliases that I use to say who I am, who Jesse is. So if you go and visit this URL, just JSWR, that's my alias that I use everywhere, .solidcommunity.net. Firstly, you can find all of this machine readable information around where my data is, who my identity providers are, and links to other profile documents, like the personal profile document that describe details like my contacts and my preferences that I might not want to share with everyone. And you can also get this in more HTML-y forms as well, so that humans don't have to go through and understand the machine readable form. So what does this actually look like in practice? So here is an application called Umai, and it's been built by one of the wonderful developers in the Solid community, Nolde Martin. And Nolde Martin volunteers about 1 day a week and just builds Solid apps and does great things. And this is the recipe manager that he's built. So you can see the flow that I was talking about. Firstly, we're going to do our single sign-on, where Noel has created this sign-on page, and I'm logging in, firstly by telling the Umai application where my pod is, where my data lives, and that's at solidcommunity.net. And it connects to my pod. Because I've already signed into my pod provider, I don't need to enter my username and password. I just authorize Umai to access my data. And now that it's logged in, this Umai application in my browser directly fetches the recipes that are in my pod and pulls them into Umai. And you can see I'm interested in pork crackling and hummus and anything chocolate, even though I'm lactose intolerant. And if we go into the chocolate cake recipe, you can see all of these different ingredients that I've written out and the recipe that I've written up. And you can do other cool things with you. But before we do other cool things, let's have a look at another way of viewing this data. So this is just something called Solid OS, which is kind of a developer playground for Solid. And you can see that living in my pod storage, along with things like my inbox, my profile, test applications data, my recipes are available here. And we can see them written in this machine-readable RDF format, where they're of type recipe. So there's a class recipe with a definition of what properties a recipe should have. We've defined the cooking time. We've defined a description of the recipe. We've got an image, a name, instructions, ingredients. All of that's available, and all of that can be read outside of the Umai application. And then if I go back to Umai, we can have a look. We can create a new recipe. This time we're going to do that by importing it from the web. So this is just a carrot cake recipe that I found online. And just in a few moments, I can import that into my cookbook. And I immediately see it available with all of the ingredients, because Noel has done lovely work of converting the natural language description into an RDF format. He's got pre-processing for that. So we can see the carrot cake recipe. We can create the carrot cake recipe. And then if we reload in the Solid operating system application, which again is a developer playground, I can see that within my files, the new recipe has appeared. So we have true data reuse across applications and true data interoperability. So that's just a very small demo on a fairly simple use case of recipes, but I think it gives you the idea of the vision of Solid and data reuse and data control. I wanted to also pull out the core concepts that are important here, in my view, beyond the specific technologies that Solid is built on. Firstly is having proper control and consent management over your data so that you can allow applications to use it for a period that suits you, but revoke access after a given period of time if you no longer want that application or service provider to use it. Very important, in my view, is data reusability so that you can not just have the information that you use siloed within an application, but you can reuse it everywhere online. Increasingly, it can be available to AI agents. They can work with that data for you within the bounds of how you permit. And in order for all of this data reuse to be possible, you need to have consensus on how to understand and interpret that data, which is not something things like LLMs provide today. They all have their own worldviews and understandings of what terms mean. So where are we at in the journey of Solid? As was introduced at the start, it was created at MIT back in 2014, 2015. So it's a long ongoing project. In 2017, Inrupt was established to commercially drive the adoption of Solid, and Inrupt's product was an enterprise-grade implementation of the Solid server. And now we've reached a point where we're ready to really push for adoption of Solid. And to do that, we need good open source infrastructure. We need people building applications. And to support that, the Open Data Institute, which is another institute that Tim Berners-Lee co-founded with Nigel Shadbolt, first for the purpose of creating open data in the UK back in 2012, and then for promoting various standards like open banking and open active. ODI has now taken on stewardship of Solid as of October 24 to help ensure that the code bases around Solid for applications, for developer experience, are continually being maintained and made robust so that we can build good applications on top of them. And also so that we can support the global developer community in being able to build out applications that are useful to them. Concurrent to this, we're also maturing the client to server standards. So until now, Solid has been a community group specification within the W3C. In October 2024, the linked web storage specification was started. And this is an official W3C working group item, the same that HTML is, the same that verifiable credentials are, which are the basis of eIDAS identity and digital identity in a lot of places around the world now. So we're reaching a point of maturity, and the standards are being given a rightful status. So, and there's also a series of very interesting deployments around Solid, and I put links in this presentation. I know you can't click on them, but I can put them in the chat after my talk to a catalog that lists some of the applications that's maintained by a community member, Jeff Sucker. But just to highlight some, one is the Portland Pass project, which is running in the US to help homeless individuals manage their documents. A use case being getting access to services when you move across state borders, which is quite difficult. That's being done with Solid. In Australia, there's a range of Indigenous health projects going on. So even before I worked for Inrupt, I worked for the Australian National University, building solid infrastructure for Indigenous populations in Australia so that they could control their health data and manage it in a way that is culturally sensitive to the Indigenous peoples of Australia. In Europe, there's also government level adoption of Solid. So a TUMI has been created in Flanders as a data utility company. And all 6 million citizens in Flanders have a Solid pod, and they have their educational credentials put into that Solid pod with their proof of a bachelor's degree or their proof of having done a nursing course. And then that can be used by those citizens to help them prove that they have the right qualifications when they go for various employment. And that's one of a number of Atumi's use cases, and a lot of the government platform in Flanders is now being built on top of Solid. So there is increasing adoption of this technology. And that's kind of where I wanted to pause and leave it open for discussion, noting that we're still running a little overtime, so I'm not sure whether we'd like to go into discussion now or leave that to the panel. I'll hand over to you to make that call.
Yeah, so thank you, Jesse. I just want to see in the room whether we have some quick questions. I see there's one question on NDN workspace already. I think you can get to that.
If not quickly while I'm screen sharing, so if you could read it out, that would be great.
Okay, sure. Kathy was asking, when you are authorizing who can see your data, is who a particular individual, or is there some way to designate a class or attribute of users with whom to share?
Both are options. So you can define a group to which you can delegate, to which you can then set access controls upon a group. You can also use something called the user managed access flow. So UMA is a authentication flow that first emerged as a branch of OIDC, or sorry, a branch of OpenID Connect, a branch of OIDC that allows you to have scopes when you request resources. So I go and fetch http://example.org/Jesse. And when I make that fetch, I don't just include a bearer token. I also include a set of scope variables that contain signed credentials indicating that I have been authorized to access this resource. And you then have an authorization service that is able to determine whether or not you should be issued that signed credential based on, for instance, having proven that you are a valid GP provider or having proven that you're a valid healthcare professional. That particular part of the specification is evolving a little bit. In particular, if you look at the credentials work streams happening within the W3C, they're now starting to look into protocols like CCAP, which is zero knowledge access passes or zero knowledge access proofs, as a means of delegated authority. And I expect that something closer to those specifications may be what is used in this LWS working group for delegated authorization.